Hello everybody, my name is Ricardo Mateus and I am with my colleague Aguma Yudi, supervised by Maran Jansen, to give this video course about ICT architecture design. I will talk about the assignment guidelines and my colleague Agung will describe the OpenCube toolkit. The outline. We start with the assignment description, then we go for linked open data lifecycle model, and finally OpenCube toolkit tutorial. Assignment description. The objective of the assignment is to use the linked open statistical data from some websites using the tools of OpenCube Toolkit to create a real user scenario to accomplish a problem that we have on society, on government, or enterprises. The expected assignment deliverables. We start with a brief plan for application use linked open data in the OpenCube toolkit. We have an expected deadline for 19 September. We identify challenges and benefits of linked open data based on collection, publishing, and of course using for your specific scenario. The expected is 21 of September. Then we have a presentation during the class of your user scenario and expectations of the architecture. So probably we'll be on class and try to help you to improve your idea and the user scenario. The date is 26 September. The task 4. We publish selected linked open data sets on internet on the expected deadlines 28 September. If you are confused about this, we can talk next week, or you can just email me. My email will be on the final of the slides. The task 5, identify requirements on an architecture. So the objective is to have a list of required desired functionality. The expected deadline is 3 of October. Task 6, we develop an architecture model. Then you can use ArcMate or BPM or UML, but this is based on your case, your real situation case. The expected deadline is 5 October. Task 7, define principles and implementation for the guidelines. The expected deadline is 10 of October. Task 8, implement the architecture and realize the user scenario, employing the OpenCube toolkit, what means that you will implement your plan, what you planned with the data sets that you collected, you treated, etc. The expected deadline is 24 October. Task 10, we have final presentation. We'll be on class to give feedback, and also we ask for other groups to give feedback also to the groups that are presenting. The expected day to present is 24 October. And finally, the final task is handing in a complete report on 4 of November. You have the final application and the final report to us. We have some suggestions of areas that you can work. Of course, we start listing portals that you can find open or linked data. We can use the OpenCube platform online, web-based, or the toolkit that you can create local installation. The first area, Area A, we suggest transparency and accountability in government. Area B, public service delivery. It can be from both private or public organizations. Area C, decision making in regulatory and legislative. This is an important area of the government, but we don't have too many projects. Area D, entrepreneurship and economic growth. For example, you are using data sets from the government to create a new business or improve a business. For example, ways They use datasets from the government to improve the deliverable of GPS information. Yeah. Here are the suggested open. Some are statistical, but open data portal list. We have almost 3,000 open data portals around the world. On the first link, we have the Dutch Statistical Office, opendata.cbs.nl. The Eurostat, we have a statistical from all the European countries. World Bank data portal, almost everything about all the world. And finally, a list of statistical portal. This is a website, a North American website, but we also have other statistical links there. If you have more examples, please send to us. Then we can improve this list. Yeah. The evaluation method will be kind of complete, but we ask to use the knowledge that you learned on the class, the reference list that you have on the report. Uh, it will be evaluated the quality of application, the replicability of the application. If it's summarized, clear objectives, the requirements, the constraints on the architecture. So please go directly on what is the problem or what is the benefits. Translation from the business needs to the architectural models and requirements is important to understand what are the problems on the government, for society, for the business, and then try to summarize it on architecture. Clear argumentation, systematic and structured approach, use of models and tools, in special the OpenCube toolkits, the validity and correctness of the architecture model, innovativeness and creativity. So please create new business model, new things, or a new way to deliver the same public services, but using less resources or more automatically. Use of figures and tables to summarize and to represent what you want to express. Use of knowledge from the class and applicable literature. We have a reference of literature on the documentation of the class. And we suggest to have a maximum of 20 pages, of course, excluding the summary, the table of context, and the reference list and appendixes. And then we go for linked open data lifecycle model. This lifecycle comprehenses the data creation, where we collect, storage, and select which data we will link it or open. Then we publish this data. We harmonizing this data between the other data we have. We cleanse the data if we need. We create metadata, and then we opening up this data set to people or locally. Yeah. The concept of open can have two concepts: open to the public, open access, and also open format. Yeah, don't mix those concepts. Finally, the final stage is the data usage, where we can link data sets. We can expand these data sets to external data sets. For example, probably you are going to this to create a new business model. We discover data. So if we uh, combine these data sets, then we can easily discover data insights, exploring data and exploiting data. The data curation is it's on all the cycle, but we insert before the data curation, after the data usage, because normally after we use, we can improve the quality of the data creation. So here we describe the stages and the steps, what they mean to us. And now I give to my colleague Agun Wayudi to explain what is the OpenCube toolkit.
Thank you, Ricardo. Hi, everybody. I'm going to explain for a couple of the next minutes OpenCube Toolkit reference architecture. OpenCube Toolkit is an example of a reference architecture created by OpenCube Consortium for statistical link open data. It is a reference architecture that contains open source components available for free use. You can freely download from http opencube-toolkit.eu. Beforehand, you need to make sure that you have already installed Java 7 or 8 in your system. As Ricardo mentions in the link open data lifecycle, there are three groups of tools according to the LOD lifecycles. The first one is creating LOD tools. The OpenCube toolkit involves several tools, for example, Tarquel, D2RQ, Grafter, R2RML, JSONstat to QB. I will explain to you after this. The second part is expanding the existing data cube, including OpenCube Compatibility Explorer, OpenCube Aggregator, and OpenCube Expander. And the last part is exploiting the data cube, which is the hardest part, which involve tools for searching, querying, visualizing, and analyzing the data cube. For example, R statistical analysis, you might probably know, and interactive chart visualization. Let's move let's move on to creating LOD tools. The objective of the tools in this group is to convert data to RDF format that is standard of linked data. Tarquel is meant to convert CSV, Excel files, D2RQ, and R2RML are used to convert traditional database data such as MySQL, Oracle, Postgre, and so on. Is for converting JSON-stat is for converting JSON structured data. Grafter is not part of the toolkit, but it's free to use and available in the internet. Let's move on to Tarquel. You can use this tool to convert flat files to RDF. The application and its syntax is available on http tarquel github.io. The application only runs in Linux, and before installing the application, make sure you have already installed Maven and Java 7 or 8 in your system. For example, we would like to convert this purchase data to RDF. There are date, hour, city store, product, total payment, and payment type. First, we tried the regular SQL script whether it works, in which we select city store and the amount customer pays. The second one is we create the Sparkwell script to convert the data into RDF. As you can see, the left part of the screen is the script and the right part is the output or the RDF data. The second tool we will discuss is D2RQ. It's used to convert traditional database RDBMS, for example, MySQL, Oracle, Postgre, Microsoft SQL, Informix, etc., to RDF. You can download and find the syntax from http://d2rq.org. Make sure that you have previously installed prerequisite applications as stated in the website. For example, the purchase data from previous example is stored in MySQL database. We need at least two steps to convert the data to RDF. First, generating a default mapping file. Second, dumping the database. Last, you can optionally run the D2R server. We will explain that later in the next slide. First step is to generate a default mapping file. The command generate mapping will map the table structure in the database to D2RQ file. The second step is to dump the database. Using the map file from the previous step, you then you then create the RDF. This tool also provides the 2R server, which has GUI for process and data management. Another tool is Grafter. It is a tool to convert XLS CSV files to RDF. You can find the software and the complete syntax from http://grafter.org. But you need to install Java 7 or 8 and Leiningen Clojure build tool beforehand. There are 4 steps to convert the data to RDF. First, creating project from the provided template from the Grafter. The second one, running pipelines so that you can feed the streaming data into the system. Third, transforming into tables that help you to query and read the data in a comfortable way. And last, transforming into graphs that is converting the data into RDF. There are other tools for creating LOD provided in the OpenCube toolkit. For example, R2ML, which you can find the software and syntax from GitHub, and cons/r2rml parser, and JSON.qb from GitHub rxtasiwis/json.qb. The last part is the second part, is the expanding LOD. These tools are needed if you have existing data cube and need to expand the cube. Expanding means adding new rows or columns to the cube as well as updating the existing data. There are 3 tools provided in the toolkit. They are OpenCube Compatibility Explorer, OpenCube Aggregator, and OpenCube Expander. However, you can skip this part if you have no previous data cube in the system. The last group of the tools and the most difficult part is the exploiting LOD. The tools included in the toolkit are for searching, querying, analyzing, and visualizing. In this tutorial, we will use R statistical analysis as an example. This is the example of R script to predict something. You can learn more about R script from many sources in the internet. For example, http://r-tutor.com. The output of the previous R script is then visualized, for example, in this graph. I think that's all for the tutorial. If you have any further questions, please contact Marijn, me, Ricardo, or Data. I hope you can find the toolkit beneficial for your assignment. Success for you!